I never know exactly how to respond to that. And that's a lot of stuff, but I actually, for the most part, have been a developer. Interesting thought. Someone was talking about career pathing and what to do yesterday at one of the panel discussions. There's a lot, especially in India, there seems to be a lot of pressure to move into management kind of stuff. Like that's a thing, right? That's an important thing. And I'm not trying to talk you out of that. I did that for a while, but I'd made a decision a few years ago that I just like coding stuff. And I moved back into it a few years ago, and I absolutely love it. It's fantastic. I don't have to talk to people. No. So we're going to talk about Docker in here, and if you're okay with it, well, I don't know if it matters if you're okay with it. I'm going to spend more time at the console probably than slides. And in some ways, that's going to be cool. I actually learned this style from Venkat, who I admire quite a bit. He's kind of got like a, hey, what do you want to do today kind of style, and just start doing stuff. What I feel like insanely comfortable in my world of Docker, have been working with it since version 0.3, which is pretty early on. I think bits initially landed in January of 13, and I started in something like April or something like that. Anyway, so I might throw a few slides up here so we have some things to look at, but there are a couple of core things about Docker that if you are new to it, you would want to know. There's a lot of, I like to demystify things. I like to look under the hood and go, what exactly is this and what exactly is that? And sometimes we'll talk about certain features, like maybe the attachment function of Docker. And that can be okay, but it's probably not what you're going to use if you're in the real world, right? And so I try to bring in some real world things, which is why I call it professional. I don't know if that, I don't know what a professional is. I get paid to do this, so I guess that's professional. How many people have used Docker already? So most people, okay. Well, maybe half, or shy people, I guess. In production? People in production with Docker? Okay, so fewer hands. And that's to be expected, I guess. I don't know what it is. There's something about Docker that has brought people out of the woodwork as far as developers go, and they absolutely want to use it. It's the shiny thing, right? But there's some really good reasons to. I think one of the other drivers as we get started is more around CI/CD type stuff, continuous delivery type things. Like I'm literally running the same bits that I was running in all the other environments. But there are some things that are kind of challenging. And you know what was really interesting when Docker was really starting to get going, when people were really starting to leverage it, the developers would use it, they would play with it, they go, this is cool, and then they go, okay, now what? What do I do? Meaning, you really almost need an orchestration tool to move this into a production environment. And if you don't, that's okay. I mean, the other option would be to be managing things through Ansible, Salt, Puppet, Chef, something like that, right? But that's another one of those challenges that, unless you ask me questions, I probably won't dive into. One of the pain points that you'll face, I'm assuming most people in here are developers, one of the pain points you'll face is some resistance in your ops teams, in my opinion. It happens very commonly. Because what they used to control is everything that landed on the box. They control the version of Java, they control the version of everything on the box, and now you've got bits that are going to be pulled technically under the covers as a tarball. So you've got a tar of things that are coming, and now they're left with an interesting question. What do I put on the box? Do I put nothing on the box? Do I put some things on the box and then some things come in the Docker? And that's one of the things that you'll need to figure out and debate within your teams. And again, if you have follow-on questions to that, bring it up as we go along. Why don't we get started? And that's not actually the agenda, so hopefully this is right. As we get started with Docker, first of all, it's written in Go. I don't know if that's important to you. It's probably one of the first really cool, hardcore productions of Go, in my opinion, outside of Google, I should say. And actually, there's a good portion of this was written in Python, and it's then transitioned to Go in the early days. I don't know if that really matters either. This slide's worth bringing up, but I'm going to, again, I want to get to more of the pragmatic stuff, but just to demystify, if you haven't seen this yet, containers. This is the traditional world, the statically partitioned world of the cloud or your data center, in which case you have a hypervisor, you have a machine that it's running on, you have a host OS, and you have a bunch of guest OSs. These are really heavy. Usually these are like 2 gig images of some, 1 to 2 gig images commonly. Again, if you have an immutable architecture, which I would highly recommend, that means a new 2 gigabyte image for any small change. You got a whole new image I need to have, and then you have to worry about how do I maintain the history of those images if I want to be able to roll back and things like that. So a pretty challenging world that doesn't tend to be a developer world, which I'm going to focus on in here. It's more of an ops world. Over here we have what a container space would look like. We have a machine we're running on, we have a host OS, but notice there is no guest OS. There are elements within a Docker container where I could say I want Ubuntu, I want Fedora, I want Debian or something, and any kind of deltas that might be necessary to support that will come. They will come with the Docker. Now, again, I'm going to demystify things. That's my goal. We've had containers before. We've had containers for a long time, actually. So one has to wonder, what did Docker do that made things different? It had to be something, right? And there are really 2 really core things that they did that I think were significant. The first is they made it really easy. Like, containers are really just namespaces and C groups. Maybe a little bit extra, but the core of it is that. And you can do all of the things that Docker does. You could do that by hand. It would just take forever. They simplified some things in really amazing ways. Like, I could spin up a container. In fact, check this out. Docker run IT Ubuntu. Boom! What just happened? Like, that is so not impressive, right? But within a blink of an eye, I have a whole new namespace in a C group. I have a whole container. I have a process running, and it's in its own little space. What we don't see, but happened, is I have a whole new network that was configured. I have a bridge network that was attached to it. There's a bunch of stuff that happened in a blink of an eye, and it made some things really insanely easy. So that's step 1, right? But that's not the whole thing. But that's an important one. The second thing that was a really big deal, because what we just saw there, that quick little blink of an eye thing that we were impressed by, we've been doing that in Mesos for a long time. Mesos actually had a Mesos container in 2009. But one thing that the Mesos container didn't do that Docker does really well is have a file format. The Mesos container was built on the fly. We would fetch different artifacts, and you would run some scripts, and it would create the environment on a sandbox that you needed. But the Docker container actually has pre-installed these things into a format that then gets tarballed. It's really layers of tarballs. So if you're familiar with the tar format, the part that's really interesting here is there's nothing really fascinating from a technological standpoint. It's a tar. It's super simple. And that's also really beautiful, right? It's really beautiful that we can make something so simple, so pivotal in this space. What we have is we have a tar that has a SHA. And that tar is immutable based on this SHA. And one of the leading things that I want you to know when we start diving into Docker is we start messing with SHAs again. That I think there are 2 types of SHAs that we want to talk about. And if you can separate out those 2 SHAs and understand and treat them separately mentally, I think you'll win big relative to how people normally learn Docker. Normally they kind of just play with it and they see, okay, I can install stuff, okay, I can push stuff. We will show some of that, but knowing the underlying of what's going on is super important, I think. It's just the same. Here's an example. When I finally learned how Git worked, the Git with the Git tree, the commit trees and the commits, and I knew how the SHAs worked, I don't think about that every day. But it provides a lot of value to me of things that I never have to think about, or generally don't have to think about. It still adds value to me, and that's what we're going to talk a lot about here on Docker. Okay, so why don't we just dive into it? I have more slides, but I'd rather not. I spun up a Docker instance. You can see I said Docker run. We'll go through some of the commands. A couple of things here. Let's start demystifying things immediately. Here I said Docker run, so I can run something, and I'm running a name here. In this case, we have a certain set of flags for run. -i-t basically says I want to be in interactive mode, the I, and I want basically a terminal connected for me with a T part of it. All right? So I'm going to have an interactive terminal that's going to be connected, which is why I switched from my terminal being on my local host to being in a different environment. I'm actually inside the container, and I'm interactive with it. If I did an ls here, I can see stuff, right? I can see that I have an environment that is not Mac-ish. In fact, it's very Ubuntu-ish, which is good. Now, the Ubuntu, let's figure that out real quick. Now, it might seem obvious that I'm running Ubuntu just because I said run Ubuntu, but what does that mean, and why is it such a short name? That's a great question. The typical names that we would have, by the way, I'm going to be very clear about what I'm doing in case you have a laptop and you're going to follow along, because you're the smart one I see in the room. Paying attention to you. All right, I hit Control P, Control Q. That popped me out of the container. That popped me out of a container that's currently running. If I would have typed exit, I would have exit the shell. Now here's what I want you to think about when you're running a container. There has to be a process inside the container that keeps the container alive, if you will. That process was the shell, bin bash by default. Now, the only reason I know that is because for Docker, when I did not type a command on Ubuntu, it has a default. It either has a default command or a default entry point. They're slightly different, and there's some significance. We can talk about it a little bit later. But we have a place where something will start by default if I don't name it. Bin bash is what was ran at that point, and currently running, actually. So if I typed exit, what happens is if I say exit within a bin bash shell, I'm exiting that process. And if there's no process, there's no container, it dies, it goes away. In this case, I hit Control P, Control Q. I exited essentially the Docker container. I'm now back on my Mac. Notice that when I ran this, by the way, that I have this SHA. That SHA. There's a shorthanded SHA that was created, which we're going to talk about in just a second. What I want to talk about right now is this Ubuntu thing. Now, when we are longhand, I would say I want to pull the Mesosphere. I happen to work on a product called Marathon, and I want version 1.4. This is the long format or namespace of a container image. Now, I'm forward referencing a number of things, but you have to start somewhere, right? The thing that's forward referenced at this point is I'm going to make a couple of assumptions, and one of them is most people are developers, and so if you're not, please identify yourself. Secondly, that you're already used to Maven. So in that space, if I were in a Maven build and I said just build this, Maven whatever, or Gradle build, it would just start sucking things down from Maven Central, right? That's the case here. I am essentially going to Docker Hub. There's a place where we have images stored. They are stored in a certain namespace. The challenge, just like that challenge exists in Maven or Nexus, is that it's a global namespace, meaning as soon as Mesosphere is owned by the company Mesosphere, you can't have Mesosphere. All right? So I just so happen to own a company that I don't often use, but I still keep it alive, if you will, called Code Mentor. Well, there's a company that started not too long ago called Code Mentor, and they often take my namespace, so it's a problem. I own the Twitter handle, though. So. Okay, so that's the full handle. Mesosphere, slant, marathon, some version. A couple of things there. First of all, this is always required. And if you're working with the hub, this is always required. It is possible to work with your own repository. Nexus not only serves jars now, but they've also served up Docker images. So you could set up a Nexus server. You can set up a Docker repository as well. It used to be really simple. It's made more complicated merely by the fact that they require SSL keys. or certificates essentially, which is a little bit more challenging to set up than it used to be, but better, right, from a security standpoint. In that case, you would probably have some kind of name. Maybe we had something on my local host, :6000 or 9000 or whatever port that particular repository is running at. So I have a namespace is taken up by the host that's going to be hosting that thing. Okay, back to this. The question becomes, well, let's start with, first of all, this is the namespace we live in. This is the container that lives in that namespace. And this is a version thing, right? The version thing is completely arbitrary. It's a string. It's a smart idea to make that intelligent, right, in some way. There's one special string, which is called latest. Latest is typically a pointer, and that pointer is to something. Here is something a little strange. It is possible, in my example, I had version 1.4. So let's say I have a Marathon version 1.3, 1.4, and 1.5. It is possible for me as the author and the pusher into this repository to set the label latest to 1.4. Let's assume maybe 1.5 is unstable or whatever, and it begs the question, why did you push 1.5 if it's unstable? The point is latest may not necessarily be the latest thing you see. You are in full control over that. So you want to be aware of that. You can also create your own labels. So I could have pushed a v15, and I might have a label called latest dev. In fact, in the Marathon team, we actually do have something called the latest dev. So if you pulled the latest dev, you would get whatever was built by our CI environment, as opposed to what was released. Two different things, okay? But there is an expectation that if I leave off the version label completely, like we see here, that I am pulling the latest. And you are pulling the latest of whatever it points to. One can assume that it's probably the latest thing, and that's probably a smart thing, all right? The goal isn't to make things complex. I just want to demystify some things. It's pointing to something. You will get to whatever the latest label is pointing to. Okay, but we still have this mystery. I have the ability to run IT Ubuntu, but it doesn't have a namespace. There are certain images that are so popular in the open source space that if you submit to Docker through a special submission process that you want a specialized name, in this case Ubuntu, then they will grant you that. But what it means is when we do a lookup on Docker Hub of Ubuntu, it will do an alias to Ubuntu, :latest, and then provide that. Okay? So that, without doing anything special, like you never talked to Docker Hub, you just created a Docker Hub repository, you would always type in whatever your namespace is, and then whatever your container name is, right? That would be the expectation. The only way you can get around that, if I could spell, is if you submit it to Docker that I have something that everybody wants and I want to create a name for it, and then they evaluate it and decide whether they want to do that or not. Some names that are probably common that you would expect. I can pull Ubuntu, do it all the time. Alpine is a very common distro now. Probably any of the Linux distros are fairly common, CentOS and things like that. Redis, Nginx. So a number of things that you would expect. I can use the short alias. All right. Okay, so that's kind of the thing. We're going to run a container. Those are images. I want you to think something though. Let's say I say Docker pull Ubuntu. It's going to notice what it's looking for. I'm looking for the latest. Notice the SHAs. I'm now pulling SHAs. So apparently I don't have the latest. I was running whatever was latest on my box. I may not go through this entire process. That wasn't my goal. I should have done that earlier. Notice that it's coming from library Ubuntu. So I'm pulling the latest of library Ubuntu, but here's what my point was. That container has a SHA. That's the container, the image SHA. Okay? That image has a SHA, and it is immutable. This is a very important concept within the Docker world. It's immutable. Everything in Docker world is immutable. Right? If you want a new image, you're creating a new image. If you're going to add something to an image and you're going to save that, you're going to save it as a new image, which means you're saving it as a new SHA every time. Okay? Now, the interesting part here, are we going to wait or not? All right. The interesting part here is, as I mentioned, I ran Ubuntu. You can see that at the top. If I say Docker PS, I can see that the thing's running. Now, the image itself has a SHA. If we went to Docker images, and I have too many of them, so let's grep for Ubuntu. You will see that my Ubuntu, the resolution is absolutely horrid. Can you guys read that? I don't know. There's the latest. There it is right there. You see that SHA that I'm pointing to? Hold on a second. No. Come on, Ken, get this right. Okay, so here's the latest right here. Here's the SHA right here. In fact, interesting thought, right? What if I copied that SHA, said Docker run IT, the SHA? What do I get? It's the same thing. We have human readable, human intelligent words we can use to represent the SHA, but the SHA is the thing. The SHA represents the image, and the image is the thing that we run. And what it really means is take these tars, start laying these tars on top of each other in the order that we've defined them, and then instantiate this process underneath this namespace in C group. That's what's really going on. Okay? Now, namespaces and C groups, you know, we didn't specify anything. You're not going to have a whole lot of constraints going on at this point, but it's possible. Okay, so we have this SHA. Let me exit out of that and look at the PS again. So I have this container. Notice that this SHA right here, that SHA right there is different than this SHA. This SHA, the one that I'm highlighting right now, this one right here, is the image SHA that when I said run, produced that SHA. That is my container. I actually don't know if I like the term container because it becomes confusing for a lot of conversations. Word's just too malleable in its meaning sometimes. We have container images, which are a series of tarballs that will then instantiate a running process inside of a running container, and there's a SHA for that. It is possible, in fact, if I'm going to kill something in Docker, so I'm going to kill, I could just copy and paste this SHA. I could do that. I could shorthand it as long as I can uniquely identify it. That works too. I have enough characters to uniquely identify it. It's good. That's one way. But I'll show you, like I do Docker all day long. Like what do I do at the end of the day? I probably do something like this, which is Docker kill, run Docker PS -Q. What that means, well, first of all, Docker PS. Docker PS is going to give me a list of all running containers at this time. So I can actually pipe things together and basically say Docker kill. Here's a listing of SHAs, and then I've killed everything that's currently running. Do you have a question?
Yeah. So when you say these are immutable, right? The properties still need to say, let's say they want to change some configuration.
Yeah, let's do it. Let's do it. Let's put it in practice, right? You know, I learned something really fascinating. I had a great lunch conversation with a friend who's from Pune, actually. And we were talking about the educational systems and how we get a lot of value if we combine them, because they both have great ideas. But one of the things he pointed out is the Indian, and I don't know this, it's all hearsay for me, right? He said the Indian culture from an educational standpoint is theoretical. Which is really great if you combine it now. Let's just do it, right? Let's do it. In fact, I have a running container. One thing I can do, since I have a container, is I can actually attach. Now, in this case, I want to attach. There's a couple other things that might be useful to know. I could say Docker PS-LQ. What is that? Well, first of all, -L means don't give me all don't give me all of PS. Give me the last running container. So it's very common, in fact, for me to run a container and then want to do something with another Docker that's going to interact with that container in some way. Then I will just say Docker PS-L, and if I just wanted SHA-LQ, right? I commonly, in fact, have aliases for these things because I just do them too often, right? So here I'm going to attach, and the odd thing is, do I have things running? I don't know. So the odd thing with attaching that you want to be aware of is, you know what? I am going to get to your point, but I'm going to take a long way. Right? The weird thing is I attached, but I had to hit enter again to finally see that I'm actually interacting with the terminal again. Let me do one more thing. I'm going to hit Control P, Control Q. This attachment thing. It's cool in a demo, right? Like, but I don't know if I've ever attached to something in production, because here's what's happening. If I say Docker attach, I attach to a container. I gave it the SHA of the container. I'm attaching to it. What I'm technically doing is I'm attaching my current terminal to the process that is the active process in that container. What am I usually running in that container? In this demo, I'm running bash. What are you probably running in production or some other environment that's not a demo? You're probably running like Nginx. If you attach to Nginx, you'll potentially see the logs if they're outputting to standard out, but you're not going to be interacting with anything. Now the question is if you wanted to enter a container and you wanted to be able to see its world and to mess with it and to debug stuff, what would you do? Well, here I am on the Mac world, right? I'm on my Mac, and I have a running container. There's it right there. In fact, why don't we go ahead and copy that SHA. What you would do is you would say execute -IT, the container, and the thing you want to run in that container. Now, what does execute do? Execute says to execute some new process within that container. I want to execute the bash shell inside of that container, and I want an interactive console. Now, here's what's cool. If I went back out, in fact, let me go out here and say Docker PS, you'll see I only have one container. The original container's running. But now, technically, underneath the covers, I have two processes running inside of that container. You also want to be careful. You may be right at the edge of memory requirements on that C group, and you might blow out the container right now just because you started or you did this. Or you did something inside that shell that's going to consume enough memory or to challenge things, right? Starting a second Java process may not be the ideal thing to do. So, but now I can start to investigate. In fact, let me exit out. Now notice I'm exiting. I could also hit Control P, Control Q here, but I'm exiting. I exited that process. I said Docker PS. I now still have a process because the original bash is still running, but now I have one. Let's go inside now, the Docker attach of that SHA. I am now inside the one shell. Let's do something crazy. Echo, hello, that text. Okay, so I created a text file. I'm going to hit Control PQ. I'm slowly, you're probably going to remind me again, by the way, your question. Slowly getting there, I think. Now, what did I do? Let's do a Docker PS, and we see that we're running. Okay, let's do a Docker diff on the SHA. Whoa. There happens to be an added foo file here, right? What does this mean? This means that you started this container, the SHA of this container was started with the image of Ubuntu, but there's been some changes within this container, and those changes are represented here. So now I can actually interact with it in a completely different way than I would interact with a VM, which is super awesome. This is actually some really good stuff, in my opinion, this alone, right? But maybe I really like this. Maybe I've established something that I'm interested in. Well, I'm going to get to that. Hold on. Let's do the execute again. So I'm executing. Now I have a second bash shell. What do I see? I see the same environment that was inside of that in my second shell. So I would expect that, right? The world that I see here, in fact, if I said host name -I, I would see that I'm in a 172.address space, which is the same space the other process is in. But if I exit here, you'll see that my host name is completely different. And I don't even know if that's valid on a Mac, but I can see that I'm on Thunderdew. Okay, so we have this container that's interesting. Maybe we really like it. So let's go ahead and say Docker commit. I have to confess something to you. And I used to be in the Navy, the United States Navy, and we used to have a phrase. It was called 50-50-90. And what it meant was if there was a 50-50 chance, 90% of the time you'd get it wrong. That's supposed to be funny. I thought you guys were mathematical, statistical. So there's an order here, and I always forget it, is my point. So it's either SHA and then name, or name and then SHA. I think it might be. Let's just call it name, foo, and SHA. Of course not. Okay, great. So I said commit this container to this image name. Is everybody cool with that? Now, what I get back is a SHA. Awesome. That is the full SHA of the new image that was created for me. But I also have a name for that, and the name is foo. And in fact, if we see this starts with CF9, right? CF9. If I do a Docker images grep for foo, you'll see that I have a foo and an image SHA of a shorthanded version of the same SHA we had before. Yes?
Keep only the incremental changes?
Yeah, how cool is that? So that's a great question, and I want to follow up on that. There was an image saved. Obviously, it happened very fast. It seemed fast to me. But what's saved is that SHA actually has a number of things behind it. One is it knows the tarball of the delta on top of the SHA that represented the Ubuntu. There's always a hierarchy. You know what SHA, what image you came from. All images have some image they came from. There are some root SHAs that are different. We could talk about that later. But that's not important, and it's probably not what you're going to be working with. You're going to be working with probably Alpine. By the way, Alpine's becoming much more popular, and the only reason is it's insanely small. But I'm showing off Ubuntu here. Okay, so let's do something new. We've got this image. Let's interact with this in a slightly different way. I'm going to run. In this case, I don't want to be interactive. I just want to run some stuff. So I'm going to say run. I'm going to say run foo. And I want to cat out the foo.txt. Boom. Now there's some really cool things going on, because within a blink of an eye, we started a whole container which has its own networking environment, has its own namespace that it lived in. It then took in the remaining arguments that were passed into the run and executed that within the context of that container, gave an output, and then disappeared and is gone. The one thing I didn't show you, in fact, is that Docker PS has a -A, which is give me all the historical information. A little challenging with all the things I do, but you can see when I say stop with a more, the last thing it ran was something that started with foo. You can see the container ID was E23. By the way, everything gets a name, so there's a name that's created for you if you don't provide it. So in this case, I don't see where it's at, but there's a name. They're goofy names, right? There it is, Modest Pain. They're usually some goofy names. Now, interesting thought. Let's go further. Let's say I want to Docker run modest pane. Oh, you know what? Start. And it's a weird thing. This is not a good example. If I had a container named that was running Nginx, I would have just started Nginx. Why might you do this? There's lots of value to it. When you're doing real Docker, production Docker, not demo Docker, right? You are probably going to pass a lot of environment variables to this thing to establish a number of things. What is the context you're working in, running in? So this is QA versus production versus dev, which means you have QA versus prod versus dev credentials for passwords to databases and things of this nature. Those things tend to be passed into the Docker image. And so it's a lot to type. You may be connecting to you may be mounting a volume. I'm connecting some file system on my Mac to the file system inside the Docker image, and that can be a lot to type. By the time you put everything together in the real world, it's a lot to type. And obviously you could create a script for that. But the other thing you could do is type it all out with a name. And when I say start this name, it starts it with all the configurations it was originally started with. And I can start and stop containers, which a lot of people aren't using for some reason, but there's a lot, once you start really using a lot of Docker containers in a production style, you probably will, because it's handy. All right, I covered a lot of stuff really quickly, right? We have Docker images, and they have SHAs. The image is completely different than the container. If I run an image, I'm running a process based on that image. You understand that some containers have default either commands or entry points. So if I said, in this case, if I said Docker Ubuntu, in fact, let's just do it, Docker run IT Ubuntu, I could say this, or I could say this, and the default actually is bin bash. It's the same thing, all right? Just like, in fact, if I go a little bit further and I say Docker run -d p, let's not do that one, p 80:80 Nginx. All right, when I say I want to run an IT, that means I want an interactive console. I want to start messing with stuff. It's a great way, by the way, to explore and to maybe try some stuff out, things that we didn't do, right? We'll do it in another console. Docker run IT Ubuntu apt get update. I'm now updating the repository for what's available to install, which I'm not going to wait for. I can then do an apt get install of curl, and now I have curl available on my system, right? You want a short, easy way of figuring out what is included in a package? Create Docker, run an Ubuntu, install the thing, and then do a Docker diff on that image. Now I know exactly what was installed. There's other ways of doing that, of course. I'm just saying, this is easy stuff. How much time do I have? Oh. We got math going on again.
30 minutes.
Okay, I'm going to ask you in 2 again. And you're going to say 11. Just say 11. Oh, you lied to me. We're going to have relationship issues. I'm joking. Okay. All I'm saying is I'm losing track of time, and I'm just doing things. Images. All right, back here. I want an interactive. What do I want here when I'm doing Nginx? Well, first of all, Nginx has a different entry point, and it's not a default command, it's an entry point, which is slightly different. Thank you. And I don't really have an interest in playing around with Nginx, at least in this example. I just want a web server running. So when I'm starting this process, I want to be able to have it run and leave my terminal and still have it running. And the way we would normally do that in the Linux world is you'd probably no-hop something, right? You would no-hop it so that it knew that if there was a cancellation of the terminal it was started from, it would ignore that signal. Great. That is -D for daemon. We're going to start a daemon or a daemon, however you want to pronounce that. Okay, so -D means, great, just run that in the background. I'm not interactive, and I want you to ignore the terminal you started from. P is slightly different. Now, it's worth going through P a little bit. I almost put a capital P there, and I'm used to that a little bit. You know what, let's just do it. Heck with this theory stuff, right? Just this talking stuff. If I say -P 8080, what I'm saying is there is a port inside of this container running at 80, and I would like you to map it to 80. That's what that means. I could map it to pretty much anything, though, right? 50, 50, 90, man. I think it is container and then out. Yeah, I think so, yeah. It's a good setup, though. What's that? So we're going to talk about, so if I say uppercase P, what I'm saying is this container has within it a port that's been told to be exposed. And we happen to know that's at 80. But, and notice I don't do anything else. I just say -D, uppercase P, and I hit enter. Okay, magic happens. A SHA was created. And now let's see Docker PS again. If I put my fingers on the right starting points, it helps. So notice that there's an Nginx running. There's a daemon running. Notice it's hard to read just because there's a lot of text and it doesn't format well. But what we want to point out here is that 000, there's a binding on that IP address of 32,769, which points to 443. But we also have 32,770 pointing to 80. So by default, if you do not do anything else and you are exposing ports in Docker, you go into what we call bridge mode. And bridge mode means that the Docker process will be listening on the host for you. It will find a pseudo-random port for you, which means what? Now, I'm sure many of you probably have started up Tomcat. And you start it up, and then you're like, I kind of want another Tomcat. And you start it up, and it just won't happen, right? Usually there's a bound address already. I believe it's on the management port that you'll see first, like it's either 8009 or 8007, something like that. It's a management port that will fail first and says, I can't do this. Now think about that. That's just the management port. How often do you even use that port? I don't even use that port. Why am I bound on that, right? So what's beautiful about Docker is I have Tomcat running in it. If I don't ever need to expose the management port, I just never expose it. I'm just going to expose 8080. Great. I would still collide on 8080, right? But now I have a pseudo-random. I can start up any number of Tomcat instances with Docker. They would just end up on pseudo-random ports. It's awesome. It's super, super awesome. So, bridge mode. Let's talk about it for a second. It sucks. Okay, that's shorthand for it. It is my assumption that as you get into doing this a lot more, you'll find some inefficiencies. There's at least 2 pain points with the Docker bridge. It's really cool. It's a really neat thing to see, certainly as a demo, right? It's awesome. People, and I have plenty of customers using this in production, so don't think that this is not production ready. But what we are talking about is some latency associated with NATing. I have a network address translation going on from the internals, or from my host, where the port is being listened to by Docker process, and then NATing it into the internals. But here's what's worse. Let's say and I'm going to give arbitrary names, right? Let's say I start up container A, and it wants to, and then I start up container B, and A wants to talk to B. What does it have to do? It has to do some kind of service discovery. Now, I don't know if we saw this or not. Oh, we did. I did a hostname-I, and we saw that the internal IP address was like a 172.address space, right? Turns out that in most likely my local host, my Mac, is at a 10.address space, most likely. So I'm running on a 10.address space. I'm going into Docker, that's a 172 address space. This container is a 172, let's say .1. This is a .2. What do we have to do? This thing cannot find this thing. It has to go external, NATed out, find out that the port is a 132.769 on the same host that I happen to be on. In other words, the IP of the host. So a 10.address space at the 172 port. It then makes an execution against that. So it goes out, it gets NATed out to the host, which then NATs it back in to container B. You can see all the inefficiencies, right? Now you kind of have to do that because you could be on a different node, but there's no way to locally find two containers that are living real close to each other. There is a thing called Docker link, which can do a little bit of magic. I don't use that in production. So, in fact, this whole compose thing, if we just back away for a second, I don't get it. There are some things about compose I really think are interesting. And it's great for maybe some testing. You would never use it in production. And it baffles me that we even consider it a real thing. And the reason why, the most significant reason why, is because I got to talk about compose now, do I? Oh, no. I'm actually there. Let me do it. Let's go into this directory. Okay, so there's an example of a YAML file that represents Docker Compose. So all Docker Compose basically says is there are two services. There's a database and a web service. The web service happens to be dot, which means my current directory. And here's the command that will run, and the volume that will be attached, and the ports that will be provided. And it depends on DB, and DB happens to be here, and it happens to be the image of Postgres. So we can see a relationship of one container to another. And it's super cool when you say Docker Compose up, because it's just going to go pull Postgres. It's going to stand it up. It's then going to make a connection for it's going to do a build of my current environment. It's going to run it. It's going to do all this magical stuff. It's cool. You would never do that in production, right? Because here's the problem. I have a web service that's tied to a database. I have one instance of thing tied to another one instance of another thing. It's a static model. The question is when you want to scale that, what do? Do you spin up like those two things together all over the place? Do you scale up the database alone? And how? How would you do that? It doesn't match the real world. It's a really neat and interesting thing. Perhaps it'll evolve into something and it'll be interesting. I don't know that. I'm saying in the state that it's in, there's no way that you would consider doing anything in production unless you have something trivial, I guess. Nothing. You have what? Yeah, it's going to make a Docker link between those two things, and it's going to be a higher efficiency of communication between those two things. But even when we get to the world of Kubernetes where we have pods, the reason why pods exist is because there's a lot of experience that Google has had through the years working with containers. And one of the things that was very consistent is they always run, it goes by different names, but like a sidecar or essentially a container by a container. It can give the illusion, and this kind of scares me a little bit, it can give the illusion to those who are less mature or less senior in this space that I want to do this. That I have some functionality in a container I want to tie to another container. When Google used pods in production, in their world, you had a primary service, and then you had ancillary containers that would then be bound inside that pod. That's the reason why a pod only has one network address space, because there's no need to have every container talk externally to the rest of the world. The sidecar containers do things like log scraping or analytics. They are ancillary services to the primary service. It is not one service calling another service. So there's a very strong difference when we talk about pods as to how they're intended to be used. And it's certainly a strong difference between that and this. Yeah. Yeah, this doesn't technically create a pod, but one could easily start to see some similarities and say, I'm driving to that. And what I'm saying is you never want to do that, especially for a production thing. Now, if you have some cool tools, I'm totally cool with how awesome. We used to have huge wiki pages of this is how you set up Postgres, or this is how you set up Redis, right? For a developer to get going, and now you just say Docker run Redis. How awesome is that? Now, it is possible to get back to the networking, and I think I'm running out of time, right? You're ignoring me again. We're going to definitely have relationship issues. I'm joking. When I don't specify anything, I'm in bridge mode. It is possible to say I could say I want bridge mode, by the way. I could say net equals bridge. But the other alternative is net equals host. When I say net equals host, I want this bound to, so when I'm living in a namespace, one of the things I get in my namespace is my own host name, and I get my own IP address scheme, and I get my own NIC, essentially, a virtualized NIC. That's awesome. When I say I want to go into host mode, in that namespace, what we're saying is never create that. You're going to just use the NIC that's available on the host. Okay, so a NIC is never. So if I went into the container, in fact, let's do it. Let's do it, right? Like if we've learned something today, we should just do it. Do a run of Ubuntu. We want one more thing. Let's do a net equals host on Ubuntu. Run. Okay, what do we expect here? Now I'm running host name. Whoops. Oh, that's interesting. Now I have some changes here, so I have to be careful. Okay, let me back out for a second. There's a reason for this that I didn't mean to get into, but now that I've done it, I kind of have to talk about it, right? Docker only runs on Linux. I'm running on a Mac. Okay, which means that whenever I'm making a Docker run this or Docker PS that, it actually is sending that command into a virtualized space, running some command and then giving me it back out. So I do have a virtual machine that I never have to worry about. I don't even think about it anymore. And its name I didn't even know, but now I know it's Moby, right? And that's the machine it's on, is the Moby machine. And in fact, if we exited here and said, no, this is a bad example. Let me go back here, PS. Notice that I have this IP, this port. That's the port that Docker's listening to on my local host, by the way. So one should say that I should be able to curl localhost at this port, and I should have Nginx. Is everybody cool with that? An alternative to what we've done is I could say, instead of -p, I'm going back way too far now. Nginx. Let's get rid of this. We'll do a -d. We said -p. We said 80:80. Now I can say curl on just localhost. But in this particular case, there is a strong difference. It should work. I'm not sure what's going on. But there's a really strong difference between what we're seeing here and what we've... When I say -p 8080 and I left the default there, I'm in bridge mode. So what is happening is I have started a process that on my localhost is running at 80 and then natting to 80 inside the container, which is strongly different than saying I want to run this in net equals host. When I say net equals host, there is zero natting. You do not have a bridge. There is not, you don't even have a network configuration at all. It's whatever the local host is. It will look strange and weird on a Mac. It will look strange and weird on a Windows platform. It will work just fine on a Linux. If this was a Linux box, we would literally be hitting, when I said -- net equals host, we'd be able to do everything right there on the local host. And of course, we'd have to sudo to get to the privileged ports of port 80 or anything under a K, right? So, all right, I think I'm down to, I don't know, 8 minutes or something. I want to open it up to questions or things that I haven't talked about that you're interested in or curious about. And if you don't, I can ramble on more, but I can't think of what I'd want to do. The what? I'm sorry. Container pruning. Oh, yeah. Okay, good question. It took me a second to register exactly what you're meaning. Whenever containers are immutable. So whenever I have changes or versions, it's very common that, you know, if I'm on version 5, the version 1.1 and 1.3 and 1.2 and 2.1, and there's a bunch of stuff that I probably never need, but those images live somewhere on your machine. There's a location for that, and you know, cleaning that up or reducing that is a very common thing to need or want to do. There's one other thing that I think is worth going through that I forgot, and that is Dockerfile. So why don't we go over here real quick and look at the Dockerfile. In this particular case, it's super simple. You're always going to start from an image. In this case, I'm starting with Python, and then I'm going to start working with it. Now, when I say Docker build on this file, what you want to know is that each one of these, this add or this run, is a new SHA. If you want to reduce the size of your, in fact, let me go back to slides. Obviously, you're going to have these slides. You're going to have a lot of detail to be able to go through, and I didn't even talk about detail about pushing, but let me grab the files real quick, and we'll look at that. Here's the original file I was using 3 or 4 years ago around using the Oracle Java within a container. So, and I think this is someone from the open source community. But the point is notice that sometimes they do like an apt-get install and an apt-get clean. So they're using an ampersand in there. Same here, run apt-get update, and then say get the, upgrade type stuff. Why? What will happen is, in fact, let's look at the next one. Do I have it? Yep. So a few slides later, I'm going to use, well, that's the same thing. I'm going to use the previous image, and I'm going to create a Tomcat instance. And notice that I have an apt-get, I have an install. Yeah. So what I could do is I could take this line, where's my pointer? I could take this line right here, put 2 ampersands there, and put that line and have one run. What's the difference? The difference is one tarball will be created instead of 2. One SHA will be created instead of 2. I can flatten things. You could call it squashing. I can squash the image. And maybe that image is more meaningful. Maybe that might be the starting point for a lot of other things. And in fact, what you want to do when you're starting to work with a Docker file is have the least changing things up front and then the most changing things lower. Because it will reduce the amount of trash that you have for pruning, for all the reasons I think you probably can decipher, right? Any kind of changes will produce more tarballs, and the more tarbars I have, the more trash I have. So, Am I out? I never end well, but. It's just the delta, yeah. Yeah, so that's a great question. I can sense the question based on your comment, and it triggers me to actually add a little bit more detail here, and that is a common question is this thing's based on Java 7. What if I would just want to update 8? Can I just create an 8 image and then add this tarball on top of that, essentially, right? Like, can I rip out a section? Never. Never. Whenever you have a new dependency change that you want to move to, everything's immutable. Everything. So that thing that changed, now I have to rebuild this image off of that change. Everything is, so there's no way to like piecemeal stuff. And even though there's tar balls under the covers which are being layered on top of each other, there's nothing within the Docker system that allows any kind of surgery like that. It seems like a good use of the word. So that's a great question. And that's the consequence. Now, it does lead to some interesting questions. Like before, when you were managing all of your nodes by your ops team and they all moved to Java 7 and now they're all moving to 8 all at the same time, do you really need that? If I have a Docker service that's been running Java 5 forever, it still works. It's still, like, unless you've touched that code, why do you care? And so we might start to see different versions of like VMs because of that. I'm not sure. We'll see. Or you might upgrade them all together. I don't know. But was there another follow-on question? No. Okay. Yes.
Can I have multiple containers on the same machine?
Absolutely. So I think you've seen that already, right? Like I could say. What's the cap? Well, that's a really hard question because here I could just start loading them up and I'm in demo mode, right? In a production world, it completely depends on whatever you think your resource utilizations are, whatever your reservations are, and making sure you have a good orchestration tool. Kubernetes and DCOS fit that category, where when you launch a Docker, it knows I need 1 core and a gig of RAM, and then it allocates that or removes that from the repo or its understanding of what is there, right? I can tell you what we're interested in doing, but we're just not close enough to do it yet, and I'm excited about it. It's humans. Humans decide this image needs a gig of RAM and a core, but it's possible that you made a mistake, and there's a difference between reservation and utilization. So what we want to be able to do is provide a report of you said a gig, but it's only ever using half a gig. And then, on top of that, we want to do machine learning and use heuristics, and based on heuristics, make those changes for you. You said a gig, but it's never crossed a half a gig, so we'll just change it. Which means now you can start to utilize more of your cluster for different things, right? So.
What is the best way to share the data between 2 containers?
Share data between containers, that's challenging as well, but because it depends on what you mean. Communication between the containers would be RESTful, probably. It would be essentially socket-based. That is common, but it requires service discovery, and that's a whole other subject we can go into. If you're sharing data, first of all, you're probably not logging in your container. You're scraping out somewhere. But if you're sharing data, then you have a file mount at some point that you agreed upon. So a couple of things there, right? I have a Cassandra container that has a mount point of the data, and then I have a client that's calling into Cassandra, so that's a TCP connection. But if I have 2 things sharing data, that's also possible. I will follow up more questions. I think we're out, yeah? She's giving me a smile, and she's being really kind. So hopefully you got something out of it, and I'll take further questions, of course. We'll step out and let someone else have the room. All right, thanks.
All right. Can we hear a